Hello, welcome. We're going to be doing section 6.3 today, which is on page 94. Again, pause right here, see if you can graph. There are 4 lines, so you're going to make a quadrilateral today. Pause it, see if you can create that graph. I'm going to start with the first one. I'm going to do them in all different colors. I'm going to do my first graph blue. This one is in point slope form. So because it's in point slope form, I want to identify my point, which remember, it's the opposite of y, opposite of x. So if it's the opposite of that x, it's going to be -4. Opposite of that y will be -9. So I'm going to start at -4, -9, which is going to be back 1, 2, 3, 4, down 1, 2, 3, 4. This is a 10 by 10 grid, so this will actually make it pretty easy. Now my slope is 3/4. That's a positive 3/4. So from here, I'm going to go up 1, 2, 3. I'm going to go right 1, 2, 3, 4 to make that a positive slope. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. That'll be the last one I can plot there. So I'm going to go ahead and connect those points. Now my next one here, I'm going to do this graph in orange. This one is in slope-intercept form. So remember, my slope is right here. It's a -3/2. My y-intercept right here is -6. So my y-intercept is going to go down to -6. 1, 2, 3, 4, 5, 6, right where I already intersected. Now my slope is -3/2, so I go up 1, 2, 3, I'm going to go back 2. 1, 2, 3, back 2. 1, 2, 3, back 2. 1, 2, 3, back 2. Now I can always go down 1, 2, 3, and forward 2. So this is my orange line, the second line. Now my third line, I'm going to go ahead and do in purple. And notice the slope right here. So I'm going to use orange again. Look at this slope, 3/4 and 3/4. These two slopes match. That's an important piece. Again, this is in point slope form, so I want to pick out my point. Remember, the opposite of y would be +3. Opposite of x will be +6. I'm going to start this at 6, 3, which will be 1, 2, 3, 4, 5, 6, up 1, 2, 3. This slope again is up 3, over 1, 2, 3, 4, or I could go down 3, back 4. Intersection. Now you can always stop once you know the intersection points, but I like to see the lines all the way through, so I kind of continue them for the whole graph. Okay, now my last line I'm going to go ahead and do in green. This one is in standard form, so when it's in standard form, I'm going to do my cover up. I'm going to say, when x is 0, what will y be? And when y is 0, what would x be? So I set up my coordinates. When x is 0, 2y equals 6, divide by 2, I get y is equal to 3. If y is 0, 3x equals 6, divide by 3, x would equal 2. So I have 2 separate points here. I'm going to go to 2, 0, right here, and 0, 1, 2, 3. Now I can count my slope and see that it goes down 3/2. I can also use, if you remember, who remembers when I was in this form that my slope would actually be -a/b? So negative a is going to be negative 3 over b, which is 2. And notice that these two slopes right here match. So again, if I have two pairs of opposite sides that are the same, those lines are going to be parallel. Down 3 over 2, down 1, 2, 3 over 2, 1, 2, 3 over 2. Go up 1, 2, 3, back 2. And I'm doing these notes before. Make sure you put your date up here, November something 2020. Okay, so I know I have a quadrilateral, and I also know opposite sides here are parallel. So when opposite sides are parallel, because of my slopes, I know I definitely have a parallelogram. Now, could I have a more specific parallelogram? Could it be well, probably not a square. This side definitely looks longer than this side. But does it look like it might be able to be a rectangle? Maybe a 90-degree angle. But I know immediately by looking at these two slopes, are these slopes opposite reciprocals? And if they're not opposite reciprocals, then I do not have a rectangle. I know that just opposite sides are parallel, it's a parallelogram. Okay, so now we're going to see what we can do here. What I tend to do is I want to create some triangles. So I start at the dots, the intersections, the vertices, and I'm going to go take this vertice and this vertice until I know that they're going to intersect. That's going to create a triangle over here. I can do the same thing with these two here. And then I'm left over with these triangles here. So I have this triangle here. I have this triangle here. If you can ever cut it up into triangles, you like that, especially when they're right triangles. You can use Pythagorean theorem. I just drew that green so you can see the separation. That the two green triangles are now congruent and the two orange triangles are congruent. That helps me see different parts here. What I may want to do is I could find different things you could do for area. There's a lot of different things. So if you have a different method that you know is going to work, try it and then come back and see if you got the same answer. A parallelogram, area of a parallelogram is base times height. The problem is you don't have like a flat horizontal or vertical line. So I do have different triangles though. I have this whole triangle, the green-orange triangle. I could find the area of the triangle, which will be 1/2 base times height. Well, this base would be 1, 2, 3, 4, 5, 6. This height would be 1, 2, 3. Now the thing is how many of those triangles do I actually have? So 1/2 of 6, I actually have 2 of them. So really, because I have 2 triangles, it's 2 times that 1/2, which will cancel, giving me 6 times 3, and I get 18 units squared. So that's how I can find the area. Now to find the perimeter, I'm going to want to use Pythagorean theorem. This is 1, 2, 1, 2, 3. So the green one is going to be 2 squared plus 3 squared, 4 plus 9. I get 13. It's going to be square root of 13. Square root of 13 here, square root of 13 here. Okay, I have 4 sides to the triangle. 1, 2, 3, 4. I know 2 sides are root 13. Now I want to find the orange side. The orange side is 1, 2, 3, 1, 2, 3, 4. Now, I like this one. This one is 3 squared plus 4 squared equals c squared. I get 9 plus 16, I get 25. Do I know the square root of 25? I know the square root of 25. I know the square root of 25 is 5. So I have two sides that are 5. Now what's really nice is that these are like terms, so I can add these together. I want the number to go first, so I'm going to go ahead and write the perimeter is equal to 10, plus I have 2 of those, so it's 2 root 13s, and its units. There we go. One thing I do want to point out is, I don't know if it's been mentioned yet this year, but there are numbers that are called Pythagorean triples. And when you have a Pythagorean triple, it's really nice because you can recognize it and answer it right away without doing Pythagorean theorem. Our most common Pythagorean triple is a 3, 4, 5. So every time you knew it was 3, 4, you know immediately it's going to be 5. You don't really even have to do the work. So 3, 4, 5 is going to work. Our second most common Pythagorean triple is a 5, 12, 13. And then any multiple of those. So with the 3, 4, 5, it could be times 2, it would be 9, 8, sorry, no. 3 times 2. 3 times 2 is going to be a 6, 8, 10. 5, 12, 13 would be a 10, 24, 26. So those are Pythagorean triples, and they're going to work every time. Okay, now getting into the notes, proven quadrilaterals are parallelograms. So all of our statements over here are going to start with if. They are our conditionals. If this is true, if this is true, if this is true, if this is true, they are all conditionals that have the same Q portion. So if this, then I know the quadrilateral is a parallelogram. So if these things are true. So our first one is if both pairs of opposite sides are congruent. So I'm going to do this one in green. So if I know these two sides here are congruent and these two sides here are congruent, then I know I have a parallelogram. My next one I'll do in pink. If both pairs of opposite angles are congruent. So if opposite angles are congruent, that means this angle over here is going to be congruent to this angle over here, and this one here would be congruent to this one here. So if I know both opposite angles are congruent, I know it's going to be a parallelogram. The next one I'm going to do in orange. If a quadrilateral is supplementary to both of its consecutive angles. So that means, let's say I have A and B here. So that means supplementary and consecutive means in order. So consecutive would mean if A plus B add up to 180, and you need both pairs. So let's say if B and C add up to 180. If they are both consecutive supplementary angles, then I know I have a parallelogram. Now my last one says if the diagonals bisect each other. So here I have, what happened to my blue pen? Okay, so diagonals here mean they cross to the opposite vertices. So I like my diagonals first. And then my diagonals bisect. Every time I see the word bisect, I know it cuts it in half. So that means this side over here is equal to this side over here. It does not mean that all four sides are the same. Those two sides are the same, and these two sides are the same. If that's true, then again, I know I have a parallelogram. So what's really nice about this is I don't need to know all of it. I don't need to have all of the pieces. But if I know one of those things, That's enough for me to say it's a parallelogram. Okay, we're going to go to the next page. Sorry, all that noise with all my pens over here. Okay, my next one, theorem 6.10. Did I miss that somewhere? That wasn't on my notes last year for some reason. Okay, so theorem 6.10, if one pair of opposite sides of a quadrilateral are both congruent and parallel. Then I know I have a parallelogram. So this means that if all I have is this one piece right here, and it says congruent, so if I say this side is congruent to this side, and I say that this side over here is parallel to this side over here. If I know these two things and it's the same pair, then I know that I have a parallelogram. And I know that this side is parallel to this side, and I know this side over here is parallel to this side over here. There we go. So the other ones, you had one of the things, but in this case, if you know that one pair has both of those features, that's enough to say it's a parallelogram. Okay, we have one proof right here. Given triangle PQT is congruent to triangle RST, so I already know the triangles are congruent, I want to say that this is a parallelogram. So let's see what they give us here. PQT is congruent to RST. That's given. Well, if I know it's congruent, I know pieces are congruent. And I want to prove that it's a parallelogram. Let's say I wanted to say that PT is congruent to RT. Could I say PT is congruent to RT since the triangles are congruent? And could I say that QT is congruent to ST? This side over here congruent to this side over here. And yeah, if I know the triangles are congruent, I know those pieces have to be congruent because corresponding parts of congruent triangles are congruent. And now I know I've discussed this before, I'm sure Mr. Christensen has too, that when certain things happen, let's say I wanted to change the sign. And I wanted to say P2 is equal to RT and QT is equal to ST. How many of you immediately know what that reason is going to be? Because all I did is I changed the sign. Okay, I didn't really change what I was talking about. I'm just changing the sign. I can do that anytime and call it definition of congruence. Well, now if I know that those are equal to each other, doesn't that mean it cut it in half? Not all four of them are the same, but that was cut in half and this was cut in half. And cutting something in half means that PR and QS bisect each other. Because that's my definition of a bisector. So if these bisect each other, can I now say it's a parallelogram? And well, yeah, I can go to the next page, and if my diagonals bisect each other, that's enough. I can now say that diagonals bisect. If diagonals bisect, then I have a parallelogram. So I can go ahead and say that. Again, make sure you're pausing as you go and see how much of it you can fill in on your own. Most of the time on a proof, I'm going to give you most of the features, most of the statements or reasons, and you fill in the next piece. So keep that in mind. I'm not going to ask you to fill in an entire proof on your own, but I'm going to ask that you can follow along. Okay, so the next one here, show that, first we're going to plot this. A is -1, +2. b is 3, positive 2, 1, negative 2, negative 3, negative 2. So here I have A, B, C, D. I like to use a straight edge because I'm going to see if I don't. Again, you do not have to. Okay, so I'm going to take this, and I'm asked to show that the vertices are a parallelogram. Well, there's a few ways you could do this. It really is kind of up to you. I'm going to do it this way. I'm going to say that I know the slope of AB. Do I know the slope of AB? And do I know the slope of CD? And I do. I do know those slopes, and those slopes are the same. If they have the same slope, that means those lines are parallel. This slope is 0. This slope is 0. Therefore, I know that AB is parallel to CD. So I need to find the slope of the other two sides here. Actually, there's different ways you could do this. So again, I can find the slope of this one. I can find the slope of the other one and make sure that they were parallel. And I can kind of see that they are. This slope is up 1, 2, 3, 4 over 2, up 2 over 1, up 2 over 1. This slope is up 2. I just calculated the slope. I could write that down. I could say slopes are the same. Those lines are parallel. If both pairs of opposite sides are parallel, you have a parallelogram. So again, that's one way you could have done it, and it is not wrong. But I could also do this. What if I said the distance of AB? What is the length of AB? It's 4. What is the length of CD? It's 4. So if they're congruent, is AB, or if they're equal, is AB equal to CD? Meaning that line segment AB is congruent to line segment CD. And if I have a pair of sides where the same side is both parallel and congruent, the same side, one pair is parallel and congruent, therefore I have a parallelogram. So really, I just proved it two different ways. It doesn't really matter unless you are led to answer it a certain way, you would have that option. Okay, this next one here, a gate is braced as shown. How do you know that the opposite sides of the gate are congruent? So again, up to the one we did up above, I can see here that this side was cut in half and this side was cut in half. So if my diagonals bisect, then I know I have a parallelogram. And that's not the end of it. It doesn't want me to just say I have a parallelogram. It wants me to say that I know that the opposite sides are congruent. Well, if I have a parallelogram, then I know opposite sides have to be congruent. So it's really nice because it works both ways. You know, it's kind of vice versa. Okay, the last one here is a little bit of a review. Can we write two equations for the line through these 2 points? I have a point, I have 2 points, which means I can calculate slope. So go ahead and calculate slope over here, and then you should start with your first line. So slope is going to be change in y's. I'm going to start with 2 minus negative 6. I'm going to put 4 minus negative 2. I get 8. 4 plus 2 is 6. I want to simplify if possible. Divide by 2, I get 4/3. Here's my slope. Now I'm going to write an equation in point slope form. Y minus equals m times x minus. I I'm sorry, I have 2 points. Which one do I want to start with? Which one do I want to use? I want to use the first one. So I'm going to do y minus the 2, x minus the 4, and my slope here is 4/3. It's going to be a fraction. You guys can do it. It's fine. Don't worry. Again, pause if you are stuck. Try to do this on your own. Y minus 2 equals 4/3 x. 4 times 4 is going to be 16/3. Well, I'm going to need to add 2 to both sides. But basically I need it to be a 2 as a fraction. So I'm going to need to add 2 over here, but I need it to have a denominator of 3. So really, my denominator has to be 3. 1 times 3 is 3. 2 times 3 would be 6. Is 6/3 the same as 2? So I'm perfectly fine. I just changed the number so it looks nicer and I can use it. This goes away, and up with y equals 4/3 x. Negative 16 plus 6 will give me a negative 10/3. I can't add those. One has a variable, one does not. This is my second equation. My first equation is this one up here. So remember, this one up here is my point slope. This one down here is my slope-intercept. Okay, good job, you guys. Keep it up. You guys are doing great. Try to stay on top of things. Don't get behind. Get caught up as much as you can. Have a fabulous day, and I will see you next time.